I'll research the SCMP article plus independent technical sources around the underlying technology, then separate verified facts, likely claims, and engineering reality so we don't get fooled by hype. Gaia Deep Research Brief. China's Zero Emission Coal Fuel Cell, ZCDCFC. Truth label, real research, early stage prototype claim. Not yet. Commercial power plant, proven climate solution, or truly zero-emission life cycle system. The article is about a Chinese research team led by Shi Heping at Shenzhen University, developing what they call a zero-carbon emission direct coal fuel cell, abbreviated ZCDCFC. China Daily describes it as a novel coal power approach with near-zero carbon emissions, published in Energy Reviews. The paper title appears as Towards Zero Carbon Emission Direct Coal Fuel Cells for Power Generation by Bin Chen, Shuozhai Tao Liu, and Heping She. The core idea, in simple language. Instead of burning coal to make heat, then steam, then spinning a turbine, this system tries to use coal more like a solid fuel inside a fuel cell. The coal is crushed into fine powder, dried, purified, chemically surface treated, and fed into the fuel cell's anode chamber. Oxygen goes to the cathode. Inside, oxygen ions move through an oxide membrane and react electrochemically with the carbon, producing electricity directly. That is why the article calls it a coal battery, but technically that wording is not exact. A battery stores energy internally and can often be recharged. This is closer to a fuel cell reactor that keeps producing power as long as coal and oxygen are supplied. The key reaction at the deepest chemistry level, the reaction is still carbon plus oxygen becoming carbon dioxide, C plus O2, right arrow CO2. That point matters a lot. The system does not magically eliminate carbon dioxide formation. The difference is that it produces CO2 in a more concentrated, controllable stream, which can be captured more easily than diluted flue gas from a normal coal plant. A prior direct carbon fuel cell report states plainly that the overall DCFC reaction is the same as coal-fired power, C plus O2 CO2, but split into electrochemical half reactions across separate fuel cell compartments. Sure, what makes it exciting? Normal coal power is thermally inefficient because it goes through a chain. Chemical energy, heat, steam, turbine rotation, generator electricity. Every step loses energy, and heat engines face thermodynamic efficiency limits. The Chinese reports say the ZCDCFC bypasses combustion and steam turbines, converting chemical energy directly into electricity through electrochemical oxidation. China Daily says common coal technologies such as IGCC are around 45% conversion efficiency and emit more than 800 grams CO2 kilowatt hour. The ZCDCFC concept is presented as a route to higher efficiency and lower emissions. Older DCFC literature supports the general efficiency promise. A University of Newcastle Coal Innovation NSW report describes DCFC as having very high theoretical efficiency due to favorable electro-oxidation thermodynamics, while also warning that many technical challenges remain before commercialization. The zero emission claim, Gaia reality check. The phrase zero emission is the dangerous part. The article says the CO2 generated at the anode outlet is captured in situ and either converted into chemical feedstocks such as syngas or mineralized into compounds such as sodium bicarbonate. So the honest label is claim reality, no combustion, mostly fair. It is electrochemical oxidation, not flame combustion. No CO2 produced, false. CO2 is produced by the carbon oxidation reaction. Zero direct CO2 emission, possible only if capture conversion works continuously and completely. Zero life cycle emission, not proven. Mining, coal prep, materials, maintenance, CO2 conversion, and final product fate all matter. World's first coal fuel cell. Too broad. DCFCs existed before. This may be the first claimed ZCDCFC version with integrated carbon management. This is the most important sentence. The technology is not coal without carbon. It is coal with a redesigned electrochemical pathway, plus built-in CO2 handling. Prior art, this is not the first DCFC ever occurred. Direct carbon fuel cells have been researched for years. A 2021 University of Newcastle Coal Innovation NSW project built and tested a 1 kilowatt modular DCFC demonstration plant, with preliminary testing reaching about 945 watt output. That same report estimated that, without carbon storage, a DCFC system could still have life cycle emissions around 647 kilograms CO2 megawatt hours at 70% system efficiency. With effective sequestration, the estimate could fall to about 93 kilograms CO2 as a megawatt hours, depending on assumptions. So China's novelty is probably not we invented direct carbon fuel cells. The more precise novelty appears to be a new Chinese ZC-DCFC architecture that combines coal electrooxidation with in situ CO2 capture, conversion, mineralization. Why concentrated CO2 is useful. In normal coal combustion, CO2 is mixed with nitrogen, oxygen, water vapor, sulfur compounds, nitrogen oxides, particulates, and other flue gas contaminants. Separating it is costly and energy intensive. In a DCFC, the anode stream can be much more CO2 rich, which makes capture easier. The Newcastle report states that DCFC avoids the normal combustion air flue stream and can produce mainly CO2, with no NOx, minimal SOx, and particulates retained in the molten carbonate electrolyte system rather than expelled as flue dust. That is a real engineering advantage. It does not make coal clean by itself, but it may make carbon capture far more practical than bolting capture equipment onto old coal plants. The biggest engineering problems, the hard parts, are serious. 1. Coal is messy fuel. Coal contains ash, minerals, sulfur, trace metals, volatiles, and variable carbon structure. Fuel cells prefer controlled chemistry. The article itself says coal must be pulverized, dried, purified, and surface treated before entering the cell. Number 2, high temperature materials. Many DCFC systems use ceramic solid oxide components and molten carbonates. These environments can be corrosive, hot, and mechanically unforgiving. The Newcastle project focused on issues like materials corrosion, anode formulation, cathode optimization, coal particle size, impurities catalysts, current collectors, and high-temperature slurry flow. 3. Continuous solid feeding. Feeding fine coal powder evenly into a sealed, high-temperature electrochemical reactor is much harder than feeding gas into a normal fuel cell. 2. CO2 conversion is not free. Turning CO2 into syngas or chemicals usually requires energy, catalysts, and often hydrogen. If syngas is later burned or converted into short-lived fuels, the CO2 can return to the atmosphere. The IEA defines CO2 utilization broadly as captured CO2 used directly or transformed into products, but utilization is not automatically permanent storage. 5. Mineralization is better, but scale is huge. Mineral carbonation can lock CO2 into inorganic carbonates, but it requires suitable minerals or chemical feedstocks and large-scale handling. The IPCC describes mineral carbonation as fixation of CO2 into inorganic carbonates, distinct from ordinary industrial CO2 use. Deep underground coal idea. One of the bold claims is that this technology might eventually tap deep coal seams, converting coal underground into electricity and sending only power to the surface. Interesting Engineering reports this as a possible application mentioned by Xie, especially for coal seams around 1.2 miles underground. That is fascinating, but I would mark it speculative. Underground electrochemical coal conversion would need extreme solutions for oxygen ion supply, reactor placement, heat management, sealing, groundwater protection, fault control, CO2 containment, and maintenance. This is not near-term infrastructure. My verdict, Avraham. This is not nonsense. The underlying science of direct carbon fuel cells is real, and the efficiency logic is strong. It could become a powerful transitional technology for countries that still have large coal infrastructure and want lower emission baseload power. But the headline zero emission coal should be treated carefully. The more accurate phrase is, open quote, high efficiency direct coal electrochemical conversion with integrated CO2 capture and possible CO2 utilization/mineralization. Close quote. That is still impressive. Just not magic. Gaia Opportunity Map. For our projects, the cleanest inspiration is not coal first. The better Avraham Gaia direction would be direction, why it is better. Biochar direct carbon fuel cell uses carbon from biomass waste instead of fossil coal. Hemp agricultural waste carbon cell links beautifully to Gaia physical first material logic. CO2 to mineral building material loop, more durable carbon lock than fuel syngas. Solar-assisted high-temperature fuel cell reactor uses solar heat electricity to reduce parasitic energy. Thermospine-style heat backbone. DCFCs are high-temperature systems. Thermal routing becomes mission-critical. Best honest next research build, a biochar DCFC plus CO2 mineralization concept brief. Same electrochemical principle.